Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at Euclidean geometry, solve circle geometry problems, providing reasons for statements, part 1. And the paper that we're going to be looking at is from the November 2019 paper 2. If we quickly just look at the work schedule, you can see here that you need to revise your grade 10 geometry and prove the following theorems. Line drawn from the center of a circle perpendicular to the chord bisects the chord. Angle at center is double or twice the size of the angle at the circle. So angle at center is twice the angle at circumference. And also the opposite angles of the cyclic quadrilateral are supplementary. Angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. So that's the tan chord theorem. All of these theorems are already on jlmaths.com. So you can have a look at the proofs of all of those theorems on jlmaths.com. Now let's get back to this particular question, which is the 2019 November paper 2. And the question that I want to look at here now is the question 9, and it says in the figure Q, P, T, S and R lie on the circle. M lies on QS such that PM is parallel to SR and PTS is equal to 145 degrees. Now, you are given the following. Q, P, T, S and R lie on the circle. Now, if you have points which lie on a circle, they call cyclic points, which gives rise to a cyclic quadrilateral. So now you need to know the properties of a cyclic quadrilateral. For example, the opposite angles are supplementary. These are the reasons that you are going to be given. Opposite angles are supplementary, which means they add up to 180 degrees. The exterior angle is equal to the interior opposite angle. And also, when it comes to cyclic quadrilaterals, you need to know that any line in a cyclic quad subtends equal angles, or you can say angles in the same segment. When it comes to parallel lines, it gives rise to the following. Our fun angles. Fun angles are the following. If you have to look at it, what's that? Corresponding angles are equal. Co-interior angles are supplementary and alternate angles are equal. So when it comes to parallel lines, you know that definitely they are going to be testing corresponding co-interior and alternate angles. Then we also need to know, for example, our properties of triangles and lines and so on. That's revision from grade 8, 9 and 10. So let's have a look at this particular question, knowing full well that we're going to most likely have a cyclic quadrilateral and parallel lines, and we're going to be using those particular reasons. So let's have a look at what we have here. So if you have to look carefully, you'll be able to see the following. You see here, you got P, T, S, and R. What is that? Yes, that's 4 points on a circle, which means that that is a cyclic quadrilateral. So if that's 145, then this angle here is going to be 180 minus 145, which is going to leave me with 35 degrees. So opposite angles are supplementary of the cyclic quad. What else do I have here? Well, if you look at it here as well, you also got P, Q, S, and T, which is another cyclic quadrilateral. 4 points on the circle are concyclic points, which gives rise to a cyclic quadrilateral. If that's 145, then that's going to equals to also 35 degrees. Opposite angles of the cyclic quad are supplementary. Also, you can see here that you got the following. You can see this arc. This is an arc here. PS is an arc. And it subtends equal angles at the circumference. So it subtends Q, which is 35 degrees, and it also, the same arc subtends R, which is also 35 degrees. So you could say that Q is equal to R, angles in the same segment. Now, having a look at that as well, so if you can also look here, you can see you got your parallel lines. PM is parallel to SR, therefore that's going to be 35 degrees there. Alternate angles. Okay, so you can see that P2 is equal to R, and that is alternate angles. Now, remember that it's important for us to try and complete as much of the diagram as we possibly can. So then we'll give it a second look. say, what do they tell us here? Q, P, T, S, and R lie on the circle. M lies on QS such that PM is parallel to SR, P, T, S is 145 degrees, and we've sifted out all of the information. So now we can also go and have a look at the following. If you look here, you can now see that, okay, you see this angle here is going to equal to that one there. So that's alternate angles, and that's, well, something that we will look for just now. So let's now go and read the question and see what they tell us. Calculate the size of Q. Let's go see if we found Q. Yes, we already got to Q. So we just need to now write down that answer with the reason. What about R? Oh yes, we've already got R as well. So you'll tick it and say, okay, I found R. P2. Let's go and have a look at P2. Oh yes, we've got P2 is 35 degrees as well. So we've got Q, R, and P2. Why is PR a tangent to the circle passing through PM and Q? So if you look at PM and Q, let's go and have a look at that. So we got PM and Q. So they're telling us that will be a circle, and they're saying why is PR a tangent? So let's go look at PR. There's PR there. So why will that be a tangent to that particular circle? Well, you can clearly see that you have P2, angle between a tangent, there's it here, and chord, there's your chord, will equal to the angle in the alternate segment, which is Q. So P2 equals to Q, therefore PR will be a tangent to that particular circle and will be converse tan chord here. So therefore we have 9.2 as well. So we've got 9.2. So now our job is to write down and retrace our steps on everything that I have mentioned so far. So therefore, let's now go and write our statement with our reasons. So 9.1.1, what is the size of Q? How did we find the size of Q? Well, what we did was we used the fact that we have a cyclic quadrilateral here. So we're going to go through it again. We said there's it here. That's a cyclic quadrilateral, and the opposite angles of a cyclic quadrilateral are supplementary. So therefore we'll say that Q is equal to 35 degrees. Q equals to 35 degrees opposite angles cyclic quad supplementary. 9.1.2. So in this particular question, they want you to find R. Now don't forget that we've already updated our diagrams. So therefore, R will be 35 degrees, and what we'll say angles in the same segment, or we can say opposite angles of the cyclic quad. So we can give one of two reasons for that one, because remember that we said that there's our cyclic quad here. That's a cyclic quad, so we were given that T is equal to 145 degrees, or we can say angles in the same segment. So we'll say R equals to 35 degrees, 9.1.2. R equals to 35 degrees. We can also say opposite angles cyclic quad supplementary, or you can say angles in the same segment. 9.1.3 P2. So for P2, now that we have that angle, we can say P2 equals to 35 degrees alternate angles. So 9.1.3 P2 equals to 35 degrees. Alternate angles, and that is because we were given, always state the pair of parallel lines that you were given. PM is parallel to SR, so we'll write that down. PM is parallel to SR, and now we got Y is, so 9.2, Y is PR tangent to the circle passing through PM and Q, and we can now write that down. So 9.2, we will say the reason for that is that P2 equals to Q equals 35 degrees. So we'll say P2 equals to Q equals to 35 degrees, and we'll say converse tan chord theorem. And that is it. So we'll come back in the next video and we'll look at question 10 and so on from the 2019 paper. Learners, if you haven't subscribed already, don't forget to subscribe to JL Maths. Also like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.